Let's take a look at this problem. We're standing at the top of a cliff and we throw a ball 30 meters per second at an angle of 30 degrees above the horizontal. And we want to know how long is it going to be in the air before it hits the ground in the valley below? What's the horizontal distance the ball travels? And what's the final velocity, the split second before it hits the ground? Of course, once it hits the ground, it's going to come to zero. But just like our one-dimensional kinematics problems, we have to have constant acceleration. When do we have constant acceleration? After the ball leaves our hand and before it hits the ground. Our hand is providing a force and accelerating it and getting it up to 30 meters per second, and then it releases it, and the only force acting on it is gravity, and then it interacts with the ground, and there's a big force from the ground that brings it to rest. We can't go from the beginning with it still in our hand and then in the air and then touching the ground. We have to break it up. There has to be constant acceleration. That means the split second after it leaves our hand to the split second before it contacts the ground. So what are we going to do with this problem? We're going to look at the X and Y motion separately. And how do we always start a problem like this, a kinematics problem? Number one, define the origin. So let's do that. We can pick the origin wherever we want. The three places that make the most sense are the beginning of the problem, the end of the problem, or the lowest point in the problem. I think most students would pick the origin to be right here. The left lowest most point in the problem. But you could pick it wherever you want. Now we want to define our positive directions. So if our origin is right there, let's have our positive x direction going to the right and our positive y direction going up. Again, doesn't matter. We could have picked the origin to be the top and the positive direction to be down and to the right. That would have made sense also. But it doesn't matter. Pick something and stick with it through the problem till you're finished. Then I like to fill in my table. I've got my x motion. I've got my y motion. We were given information about the initial velocity. And the initial velocity looks something like this. I'm going to expand it a little bit. And it's at a 30-degree angle with respect to the horizontal. So we could break this up into an x component, which is going to be 30 cosine 30 degrees, and a y component 30 sine 30 degrees. So I can start filling in some of this information. I know my initial velocity in the x direction and the initial velocity in the y direction, and those are both positive. But I also know my final velocity because my acceleration in the x direction is 0. There's no horizontal acceleration. The only force acting on this object is gravity, and that acts in the vertical direction, in the y direction. So my delta x, I don't know. That's what I'm solving for. My delta y, I do know. It starts at h and it ends at 0. So delta x is what I'm trying to find. That's an unknown. And delta y is final minus initial. negative 50 meters. I do not know my final y velocity, but I do know my acceleration, don't I? 9.8 meters per second squared. In what direction? In the negative direction. And I don't know my times. So if we look at this, we're missing information in the x. We can't solve that. We've got enough information in the y direction, though, to fill in everything there. And what links these two? Time. The time is the same for the x and y coordinates for the ball to get to that point. They are connected. So these have to be the same. So we can use the y motion to get time. Then we can plug that into the x motion and solve for distance. So I'm going to use an equation that's missing v final. Now I can plug everything in that I know. And solve my quadratic for time. So negative time doesn't have any physical meaning to us, so we'll throw that root out, and we'll say the time it takes is 5.07 seconds. Now we can look at our x motion, and we know that it's moving at 30 meters per second times cosine of 30 degrees. That's the velocity. So if we know the time, we can just multiply those two together to get the distance. (131.7 meters). Finding v final, we can just go ahead and do the same way. We already know the x coordinate. Now we can find v final in the y direction. I got negative 34.7 meters per second, which is good because I know it has to be going down the instant before it hits the ground, and that's my negative direction. So I can put these together. I know I have a v sub x in this direction, 30 cosine 30 degrees, and I know I have a v sub y in this direction, 34.7, pointed down like that. And the red arrow is what I'm trying to find. That's the vector v final. And I can write it like this. And we can solve for the angle also. So two-dimensional kinematics problems, we can split them up into the vertical component and solve that like a one-dimensional kinematics problem, and a horizontal component and solve that like a one-dimensional kinematics problem. Something usually links them together. Usually it's the time.